Hello and everybody, what is up? I'm here, I'm recording on the computer, that way you guys can see me and say hello. What I'm gonna actually do is cut this off because I'm kind of hunched over my computer right now and you guys don't want to be staring at my nose all the time. It's weird. I want you guys to take a look at this velocity versus time graphing activity and we can go from there. So here's what you'll be doing for homework today. We're gonna bring that down. We're going to start in on this. I'm going to write my name down. I am Mr. Fabianski. Oops, spelled my name wrong there. And we are working on a velocity versus time graph. All right. So let's move on up here. So it says graph the following, then use just the graph, not equations, to answer the questions below. Looking at this, we have the time and the velocity. The graph has actually already been done for us. I'm going to darken in these dots. That way you guys can see them a little clearer. And I know I always tell you never, ever, ever connect the dots. We're all about drawing the trend lines. However, this time it is okay to connect the dots. Why? Because we're looking at intervals for the most part. We're not drawing a trend line to see with data points that we've collected. We're looking at intervals. So we're going to do our best to draw these trend lines. I'm actually going to try and do my best here. Hopefully I don't let you guys down. Let's see. We're going to throw one line. I should probably do these on a different color. Let's do green. That way we can see them. I'm going to throw one line down there. Not too bad, right? One line across. Pretty good. Your old teacher isn't doing too bad. One line down here. Hopefully you guys can draw a little bit quicker than I can. Look at that, I touched something on the computer. This is cool. You guys are getting the raw uncut footage. Okay, no editing going on here. Number one, because I want to be real with you guys, show you that I make mistakes too. And number two, I'm not quite sure on how to do the editing. So yeah. Maybe the more I make of these, the better I get. You guys have seen the YouTube channel, so you guys know all about my other videos, my other teaching videos. These are just many more to come. So anyway, back to this. So we have our lines now drawn, and we see we have these intervals. And what we want to do is we want to find the distance covered over the intervals A, B, C, and D. Those intervals are from 0 to 5. We have another interval from 5 to 10. We have another one from 10 to 15. And then our last one includes the entire length from 0 to 25. So I'm going to show you how to do maybe one of these, maybe two, and then cut you guys loose. You guys can work on this on your own. And then there's a second question and a third question to look at as well. So let's take a look at this first part. We're going to go from 0 to 5. So here's our 0 mark. Here is our 5 mark. Throw those in a little bit of highlighter for you guys. Remember, as we discussed in class, what you want to do is you want to create a shape. You can either choose a triangle or a square. I'm going to choose a triangle because that's what best fits this area. So I'm going to drop down. Sorry about that, guys. Oops. I'm going to drop down here, a triangle. This touch screen is extremely sensitive. I do apologize. There's our triangle. And you can see what I'm now going to do is find the area under the curve. And remember, under the curve means under the line and always to the x-axis. So if we had something below the x-axis, we're still looking under the curve, but now we're working up to the x. So in order to find the distance, we need to find the area of this shape right here. It is a triangle. So it is 1/2 the base times the height. 1/2 is a constant. The base here would be 5, and the height is 30. All right. So now we are multiplying 1/2 times 5 gives us 2.5. And then we would multiply 2.5 times 30. You guys can operate this however you would like. So please do that for me. You do this, you get 75. Don't forget your unit, meters, 75 meters. Remember, it's always area under the curve. All right. So you're doing this for all of your intervals. That was the 5 to 10 interval. We would need another one for the, excuse me, that was the 0 to 5. We would need another one for the 5 to 10. We would need another one for 10 to 15. And then I end up having you guys find all of the intervals because you need to add them all up in order to find 0 to 25. Just going to erase what I just wrote here because I want to show you, make sure you understand these intervals that you're looking at. If we look, we see another interval here, 0 to 5, 5 to 10. I don't know what's going on with me, guys. This is a rectangle. We know how to find the area of that shape. When we get 10 to 15, we notice that we have a weird looking shape here. Well, don't fear, guys, because you could divide this up into a triangle and a rectangle. You would add those two together to get the 10 to 15. Then finally, we end with yet another rectangle and another triangle. So please find all the area under the curves. Those are your distances, and answer the 4 questions up top. Now you can either hit pause or continue to watch this and work at the end, but we're going to move on to question number 2 now. And we need to find the accelerations. So what I'm going to go and do is I'm going to erase all of this stuff that I had in here. That way we just kind of clean this out a little bit. Now what we're looking at doing is finding the accelerations. And if we remember, acceleration is determined by calculating the blank of a velocity versus time graph. Do you remember what that is? Correct. That is the slope. So we are looking at the slope of these time intervals. 0 to 5. So we're looking here to here. We're finding the slope of this line. From 10 to 15, we're finding the slope of this line. And then from 20 to 25, we are finding the slope of this line. Look, I was pretty nice. I didn't make you find the slope of this line because I know you know what that is. That slope happens to be a goose egg. That is 0, right? That is a 0 slope. Okay, so let's do one slope calculation together and then I'll leave you with the other ones. Let's actually choose to look at this slope right here, the 10 to 15 slope. Remember, slope is determined by taking the change in y over the change in x. That would be y2 minus y1 over x2 minus x1. Doing this out, let's just throw our coordinates in there. That way we know this is xy coordinate 10, 30. This is xy coordinate 15, 20. Going through, we're going to do the y's first. So it's going to be 20 minus 30 over 15 minus 10. This will give us an answer of 10 over 5, which gives us a slope of 2. Now, remember that up here, that's a negative 10, so this comes out to be a negative 2. And your slope, don't forget your units. You took y over x, so the y is the meter per second. The x is the second, so that would be meters per second squared, and you have your slope. So now all you need to do is find the slope of this line and this line. Now finally, number 3, what is the sum of the accelerations? Okay, So I had you determine the 3 accelerations that were moving. The other 2 accelerations, line segment 15 to 20 is 0, as well as 5 to 10 is 0, so they really don't factor in. Now, if the velocity of the graph, like in this case, this is final, and this is initial. If the velocity of the final and initial on the graph, will that always be 0 like in this case? All right, so I just want you guys, you really don't have to show your work, but I want you guys to think about this. Will the velocities always be 0 when you add them up together? Do you have to go up, do some stuff, you know, I don't know, and then come down? Do these velocities always have to match? That is the question I'm asking you. Or can you have something that maybe goes like that, you know, where they don't match? This is up for you to decide. So I want you guys to try and figure that out. Answer the questions to the best of your ability. I will be checking this. So if you have any questions, please feel free to email me or contact me through Teams. I wish you guys all the best of luck, and I will see you in the classroom. Have a great day, everybody. Mr. F saying, remember, physics is part of your life. Without it, we wouldn't have gravity. All right, take care, everybody. Bye-bye.